Okay, let's go over some of these problems together. I'll be kind of going through them fairly quickly, but hopefully you can follow along. The first one's a circle. We start with our circle form. X squared plus y squared is equal to r squared. That's the equation of a circle. What we need to find is the radius, and then we're done. So for the radius of this circle, 1, 2, 3, 4, 5, 6, r is equal to 6. So the equation here of our circle is going to be x squared plus y squared is equal to 36. That's 6 squared right there. And that's the solution. This works when the circle is centered at 0, 0. That's the key thing. Make sure in this case the circle is right at the origin. Let's move on to number 2. Again, it's a circle centered at the origin. My radius in this case is 1, 2. R is equal to 2. X squared plus y squared is equal to r squared. X squared plus y squared is equal to 4 in this case. We plug the 2 into here. This is our final solution. Okay, let's go to the next one. In the next one here, slightly different because the circle is not at the center of the circle is at a different place. Let's find the coordinates for this. The center of this circle is 1, -3. The radius in this case is 1, 2. R is equal to 2. So our equation will be, based on this center, we have x minus 1 quantity squared plus y plus 3 is equal to the radius squared, which is 4. And that's our solution for number 3. Number 4, the center of this circle is at -3, 2. The radius of this circle is 1, 2, 3, 4. So r is equal to 4. So we have x plus 3 quantity squared plus y minus 2 quantity squared is equal to the radius squared. So we take 4 squared, which is equal to 16. That's our answer for the next one. Let's go to the next problem. Number 5, number 6. These are ellipses. The ellipse is centered at the origin. Let's start off with the standard form, x squared over radius in the x direction squared plus y squared over the radius in the y direction squared is equal to 1. What we need to do is find Rx and Ry and plug it into the equation. Rx, 1, 2, 3, 4, 5. So that's 5 there. And 1, 2, 3, that's Ry. So plugging that in, we have x squared over 25 plus y squared over 9 is equal to 1. Because again, Ry, the radius in the y direction is 3, so when we square that, we get 9. This is our solution for the ellipse. Again, we have another ellipse, again centered at the origin 0, 0, so we can use this same kind of equation form. We need to find Rx and Ry. 1, 2, 3, 4, 5, 6, 7. Radius in the x direction is 7. 1, 2, 3, 4, 5, 6. Radius in the y direction is equal to 6. So we have our equation x squared over 49 plus y squared over 36 is equal to 1. That's our final solution. And again, let's just see where it came from. We took this and we squared it. We took this here and we squared the 7 as well. 7 squared, 49. 6 squared, 36. Again, this is the way we do it for these two ellipses where the center is at the origin. Let's move on. Number 7, hyperbolas. The form for a hyperbola that goes up and down, y squared over ry squared minus x squared over rx squared is equal to 1. In this case, we need to find the value of ry, the value of rx. The ry value is 1. The rx value is 1, 2, 3. So we plug these in, and we end up with y squared over 1 squared, which is 1, minus x squared over 9 is equal to 1. That's our solution for the hyperbola. Next hyperbola, again, centered at 0, 0. In this case, we see that it's going left and right. So it's going to have this form where the x squared comes first. Let's figure out what each of these values are. The radius in the x direction is 2. The radius in the y direction is 1. I plug those values in. Just to be clear, I'm using this bounding box right in here as my kind of, this is the box that creates the asymptotes. It is 2 from the center, it's 2 across. From the center, it's 1 down. So that's where I got these values of 2 and 1. I get my final answer of x squared over 4 minus y squared over 1 is equal to 1. Again, what I do is I take both of these values and I square it as I plug it into my hyperbola form equation. Okay, let's keep going down here. Number 9 and number 10, the difference with these equations is that now the ellipse is not at 0, 0 as its center point, so we need to carefully figure out where the center point is, and in this case I believe it's right here, and the coordinate of that is -1, 2. Let's figure out the radius. We have 1, 2, 3, 4, 5, 6. Rx is equal to 6. The radius down or up, 1, 2, 3, 4, 5. Wait, 1, 2, 3, 4, 5. So Ry is equal to 5. And now our equation for a translated ellipse, x plus 1 squared, where we take the -1 and put it up here, x minus -1, divided by 6 squared, 36, plus, ellipse is plus, y minus 2, and the 2 came from the coordinate of the center, divided by 25 is equal to 1. That's our ellipse. Let's do number 10. The center here is at coordinate -1, 4. The radius in the x direction is equal to 4. The radius in the y direction is equal to 2. So we have x plus 1 quantity squared over 16. That is, let's see, 4 squared is 16 plus y minus 4 quantity squared over 4. In that case we have 2 squared is 4, and all of this is equal to 1. Let me move this down so we can see it a little bit better. And there is the answer for number 10. Okay, moving down. Number 11, find the equation of a parabola. Let's start off with a reminder. X squared is equal to 4py, or y squared is equal to 4px. We're going to use either one of these. If we have an up and down parabola, we're going to be using this x squared form. If it's a left or right parabola, we're going to use the y squared form. So let's figure out which one we use here. I'm going to plot these points, 0, comma, -1/16. So this tells me that my parabola, which is centered at, which has a vertex at the origin, is going to go down. That's going to then dictate the x squared version. So x squared is equal to 4py. I now need to figure out what p is. P in this case is equal to -1/16, so I plug that into my equation. X squared is equal to 4 times -1/16 times y. So x squared is equal to -1/4 y. And that's my solution for number 11. Number 12. I'm going to sketch this out again as well. Each time I sketch it out, just to make sure, 0, -1/8. That means my parabola goes down because my vertex is at 0, 0 in this case. That's a given. So again, it's the x squared type of equation. So x squared is equal to 4py. What is the value of p? Again, p is equal to -1/8. So I just plug this value of p into here. I get x squared is equal to -1/2 y. And that's solution for number 14. Let's go to number 13. Let's draw this one out. It's a little different. It's the directrix. So, y is equal to, think of it as y is always -1/72. So this is the equation y is equal to. That means my focus is on the other side. That means my parabola goes up and down like that. So again, this is another example of an x squared type of parabola. So x squared is equal to 4py. Again, what is the value of p? In this case, notice here, from vertex to focus, it's going to be the opposite of 1/72. So it's going to be 1/72, positive. So I took this negative because the directrix is down here, but I'm interested in this focus distance, which is this, in this case, going to be a positive 1/72. So x squared is equal to 4 times 1/72 times y. X squared is equal to, let's see, 72 divided by 4, 1/8. So 1/18 y, and that should be the answer for number 13. Last one, let's do this one. Let's graph it out. X is equal to -1/4. That's this right here. So if that's my directrix, my focus is going to be on the opposite side, and my parabola is going to be left or right type. And so in this case, finally, we have a y squared type. So I'm going to use that as my starting equation. Y squared is equal to 4px. And now I need to find the value of p to plug that in. P in this case is the distance right over here. P is equal to 1/4. It's going to be the positive version. Instead of negative 1/4, P is 1/4. The directrix was to the negative side. The focus is to the positive side here. So in this case, I'm going to plug in 1/4, and I'm going to get y squared is equal to 4 times 1/4 times x. Y squared is equal to x. And that's the solution for my number 14. Okay, let's continue on. Number 15. Oops, skip too far. Let's go down to number 15. We're going to write some circle equations here. Circle equations. Let's start off with the standard form. X squared plus y squared. Well, actually, this has center at 16.5. So what I'm going to do is x minus 16 squared plus y minus 5 squared is equal to the radius squared, 1 squared, so that's equal to 1. And this is my equation for my circle with radius of 1 at 16,5. We could do this one similarly. We have x minus 5, don't forget the square, plus y minus a negative 3, that's plus 3, squared is equal to 7 squared. Because our radius is 7, we plug that in, and that's equal to 49. So we could simplify it and write it out like that. Okay, next one. Circle is at 0, 0. We have a point, though, that's at 2, negative 8, or negative 2, negative 8, all the way down here. So our center is here. We have an equation x squared plus y squared is equal to r squared. Because it's centered at the origin, it's x squared plus y squared. But we don't know what the value of r is. Unlike these problems above where the radius is given to us, the radius is not given to us here. We need to figure it out. We have the radius here, though. It's the distance from 0, 0 to negative 2, negative 8. So I'm going to use Pythagorean's theorem where I have a triangle of 2 and 8, and so this other edge is going to be the square root, or let me do it this way. I'm going to say c squared is equal to 2 squared plus 8 squared, or actually let me use the variable r. R is the radius of the circle, which is also the hypotenuse, which is we typically call c. So r squared is equal to 4 plus 64, which is equal to 68. And look, we have r squared is equal to 68, and actually I want r squared. I want to put r squared right there. So I just put 68 right there, and I'm done. X squared plus y squared is equal to 68. Let's do one more of these. Again, let's do a little diagram here. Negative 8, 3. We have this point right over here. We need to figure out the value of r. Think of it as a little right triangle here. The height is 3. This length is 8. So r squared is equal to 3 squared plus 8 squared, which is equal to 9 plus 64, which is equal to 73. R squared is 73. Our standard form for a circle at the origin, again, x squared plus y squared is equal to r squared, and in this case r squared is equal to 73. So there we have our equation for that circle number 18. Let's keep going. ellipses now. Okay, for this ellipse, let's sketch it out. We don't have to be exact, but at least let's just kind of sketch it out. We have an ellipse with values here, and I'm just going to write 7 here, a distance of 7, and then in the y direction I have a distance of 11. And this is actually good enough from a sketching purpose, and it gives visually the information that I need. X squared over the radius in the x direction is 7. 7 squared is 49. 7 squared plus y squared over 11 squared is equal to 1. 11 is the height of the radius, or the radius in the y direction. So then I come over and I square that right there, 11 squared. So I could write this as x squared over 49 plus y squared over 121 is equal to 1. That's my solution. Number 20. Don't let the square root scare you. It will not be too difficult. The height of this is square root of 130. That's from this information here. Those are my 2 points there. Then I have my other 2 points. These are going to be at with a distance of 2 root 15. So I have my Rx, my radius in the x direction. I have my radius in the y direction. I have x squared over Rx squared plus y squared over Ry squared is equal to 1. So these are the values that I'm going to be plugging into my equation. This works because I know that the origin is at the, or the center of this ellipse is at the origin. So now I have x squared over 2 root 15, don't forget to square this, plus y squared over, now in this case, square root of 130 squared is just 130, so I'll just write that right there. And then I just need to go one step further, x squared over 2 squared is 4. 4 times square root of 15 squared, that will be 15. 15 times 4 is 60. Plus y squared over 130 is equal to 1. That's my solution there. Okay, a little different now. In this case, it's not centered at the origin, so because of that, I need to write it like this. X minus negative 6, that's x plus 6. And I'm just going to save what I put in the denominator for just a second because I want to finish off the center stuff. X minus negative 3, that's going to be x plus 3, quantity squared. Over, now, the width, that's my x direction. That's my Rx. I'm given Rx. I'm given Ry. That's my height. Well, actually, I shouldn't say that. My height and width are twice the value. So actually, I need to divide that by 2. So let me redo that a little bit. The total height is 12, so half of that is 6. The total width is 8, so half of that is 4. So this is my Rx and my Ry, and I need to square those. So 4 squared is 16, 36, or 6 squared is 36, is equal to 1. That's my ellipse. And this one here, let's start off with the top part. X minus negative 5, that's x plus 5. And then I also have x minus negative, or y minus negative 10, y plus 10. The width, I need to divide that by 2, so Rx is equal to 7, and then I square it, 7 squared. My height is, half of that is 10, so I square that, and I get 10 squared right there. And all of this is equal to 1, and that's my solution for 22. I'm going to stop right here.